Hi, this is Mrs. LaBarbara. This is Physics Chapter 5, Uniform Circular Motion and Universal Gravitation Video 2. Today's topic is Mathematics of Circular Motion. The objectives are to understand the relationships between quantities, to be able to apply relationships to solve problems, also to be able to apply equations to solve problems, and select graphs between variables. Here are the equations for circular motion. Average speed equals 2 pi r over t. And this equation is not in your reference table. This is derived because in a circular motion, d equals to 2 pi r and t equals to period. Acceleration, that's a centripetal acceleration, equals v squared over r, which is in the reference table. F net equals ma is in the reference table, so F net for centripetal force is the net force equals to m v squared over r, because this is centripetal acceleration. When you substitute v equals to 2 pi r over t, you can derive another equation. In all these equations, m is the mass, v is the speed, r is the radius, t is the period. Since uniform circular motion, the speed is constant, there is just one speed. There is no vi, vf, because vi equals to vf. Let's take a look at relationships between quantities. AC equals v squared over r. According to this equation, A and r are inversely related. That means when r doubles, A halves. Here is a graph of inverse relationship. It's a curved down graph. Now AC and V are direct squared. That means if V doubles, AC quadruples. And here is a graph, is a parabola going upward. AC and M are not related because M is not in this equation. So when M changes, AC does not change at all. Now, in all these equations, in uniform circular motion, you need to know that velocity is constant with time. So is acceleration and centripetal force. They are all constant with time. So the graph looks like this. It's a straight line, doesn't change with time. Let's take a look at the first example. Analytical is practicing a centripetal force demonstration at home. She fills a bucket with water, ties it to a strong rope, and spins it in a circle. Anna spins the bucket when it is half full of water and when it is quarter full of water, in which case is more force required to spin the bucket in a circle. Think about it, F equals ma. So more force is required for more mass. So half full of water requires more force. A quarter full of water would require less force. Okay, so more force is for half, less force is for a quarter. This is because F net equals mv squared over r. Force and mass are directly proportional, so the greater the mass, the greater the inertia, the greater the force is required to change the motion. Another example. Diagram shows a 5 kilogram car traveling clockwise in a horizontal circle of radius 2 meters at a constant speed of 4 meters per second. If the mass of the car was doubled, what happens to acceleration? Let's see, acceleration equals v squared over r. There is no mass in this equation, so it doesn't matter what happens to the mass. Acceleration is unchanged by the changing of mass. Another example. This is a little bit different. A 60 kilogram adult and a 30 kilogram child are passengers on a rotor ride at an amusement park. When the rotating hollow cylinder reaches a certain constant speed v, the floor moves downward. Both passengers stay pinned against the wall of the rotor as shown in the diagram. What force provided centripetal force? Well, centripetal force pointing toward the center of the circle, so it has to come from the wall of the cylinder. And that is called the normal force. Normal force is coming from a surface supporting the object. What is the frictional force? Magnitude and direction for both the adult and child. Let's think about as both passengers get pinned against the wall, they are not moving in a vertical direction. So all the vertical forces has to cancel out. We already know there is gravity in the vertical direction going downward. So there must be an upward force to overcome this gravity. That upward force is friction force. So for the adult, the friction force is upward. That equals to the gravity of the adult, which is 600 newtons. 60 times 9.8 or 10. And the friction force for the child equals to the gravity of the child, which is 300 newtons. Both friction force are upward to overcome the gravity force. Another example, a go-kart travels around a flat horizontal circular track with radius 25 meters. The mass of the go-kart with the rider is 200 kilograms. The magnitude of the maximum centripetal force exerted by the track on the go-kart is 1200 newtons, which change would increase the maximum speed at which the go-kart could travel without sliding off track. That means what affects the speed? Coefficient of friction, the radius. Well, let's take a look at the speed equation. Speed equals 2 pi r over t. So in this equation, v and r are directly related. So when you increase the radius, v increases as well. The answer is C. Now let's apply the equations to solve problems. So we have 3 equations. Here are the procedures. Identify the given and unknown. Choose the equation, substitute a number with units, and answer with units. So these are the same procedures since we started kinematics. Take a look at the first example. Combined mass of race car and its driver is 600 kilograms. Traveling at a constant speed, the car completes 1 lap around a circular track of radius 160 meters in 36 seconds. What is the speed? Speed for circular motion is 2 pi r over t. Substitute everything in, you have 27.9 meters per second. Next question. On the diagram, draw an arrow to represent direction of the net force acting on the car. 180 is at the position A. So we know the net force is pointing toward the center. So net force is pointing toward the center, just like that. C, calculate the magnitude of the centripetal acceleration. Well, centripetal acceleration, according to the equation, equals v squared over r. Here is v and r. We substitute everything in. You have 4.87 meters per second squared. Again, centripetal force is also pointing toward the center. A centripetal acceleration is also pointing toward the center because acceleration and force are always in the same direction. Another example, a 95 kilogram halfback makes a turn on the football field. The halfback sweeps out the path, which is a portion of a circle with radius 12 meters. The halfback makes a quarter of a turn. That's a quarter is 1/4 of the turn in 2.1 seconds. Determine the speed, acceleration, and net force. Well, let's see, write down what's given. M is 95, R is 12, and T is the period. Since a quarter is a quarter, 1/4 of a turn is 2.1 seconds. So for the whole thing, whole lap is 4 times 2.1 seconds. Find V, A, and F net. V equals 2 pi r over T. R is 12 meters, and T is 4 times 2.1. So after you put everything in, you should get 8.97 meters per second. Acceleration equals v squared over r. Substitute in, you have 6.71 meters per second. F net equals mass times acceleration. You should have 637 newtons. Another example. Determine the centripetal force acting upon a 40 kilogram child who makes 10 revolutions around cliffhanger in 29.3 seconds. The radius of the barrel is 2.9 meters. Let's see, these are given mass, radius, and T. T, since they are given us 10 revolutions, T is for 1 revolution, 1 lap. So 10 is 29.3, 1 is 2.93. So once you figure that out, we can figure out everything else. Centripetal force equals v squared over r. So to find v, we use 2 pi r over t. You'll have plug everything in, you should have 6.22 meters per second. Then you can find A, acceleration. Then finally, you'll find the net force, which is 532 newtons. That's it for today. Thanks for watching. See you next time.